Algebra 1, we are going to work on combining rational fractions with common and uncommon denominators. All right, so we're going to start off first with common denominators. So when we have common denominators, one of the things we have to be aware of, even with this early first problem, we have to be aware of that negative. And because there are two terms that are in the numerator, we have to make sure that let's make this nice and thin, that we distribute that negative to both of those. Both of them, that's a common. So we're going to have m minus 4n minus the quantity in the numerator all over the denominator. So that next line should read m minus 4n minus m plus 3n, because that negative gets distributed to the m and to the negative 3n. And that is all over 6, whoops, not yellow. That is all over 6mn. My marker is not working. Now we're going to combine like terms. So we have like terms of m and negative m. Those cancel. And then we have like terms of negative 4n and positive 3n. And that's going to combine to negative n. So we have negative n over 6mn. And now we can simplify it even one more. We're going to cancel the n's. We can cancel because this is being multiplied. And when we cancel the negative n, we're just canceling the n, and we have to represent that negative. So this would be our final answer. You could have 1 over negative 6m. That negative can be anywhere. It can be out here also. Or it can be this, or it could even be in the denominator. Typically, you won't see it in the denominator. That's number 1, starting off nice. All right, so we have u plus v plus. Now, I'm not going to do the quantity only because we can logically understand that that's not going to affect any of the signs, because a positive 1 will just keep them. So I don't have to show the distribution, but we are distributing a positive 1, but it won't change it, so let's just write it. So you have 2u plus 2v over 10u cubed v squared. Now, we cannot cancel the u's because it's being added to 2v, and we can't cancel the v in the numerator because that's being added. So a lot of students would want to cancel this u with one of these u's, guys, and they would want to cancel one of the v in the numerator with one of the v's in the denominator. But you can't do that. You cannot do that. What you can do, however, if we look at that numerator, we'll always want to look, can we factor? We can't combine them because u's and v's are different, but we do notice that both have a factor of 2. So we can take that 2 out of there, and we get u plus v all over 10u cubed v squared. And now, because this 2 is being multiplied by this quantity, it's looked at as 1, so we have multiplication of 2 things, and we have this 10 that is multiplying, so we can cancel those. So we can cancel the 2 and the 10, but we can only do that once it's been factored out. So that leaves me with u plus v over 5u cubed v squared. That would be my final answer. That's a tricky one. Starting off pretty tricky. All right, we have like denominators. We have addition. So we'll just meld all of the numerators together, and we'll put it over the denominator. So we have like terms. We have x's, which makes 8x. We have y's, 4y, and negative y, which makes 3y, all over 12y squared. Now I know you look at 8 and 12. 8 and 12, you want to simplify. You can't simplify. And I know you see y and y squared. You can't simplify because of the addition between those. These things aren't multiplying each other, so you can't cancel any of these. And there's nothing that you can factor from 8x and 3y. So those are going to stay. So this is actually our answer. This is the simplified answer. This one is what you see. We have 4x minus 5x. I don't have to show the distribution because there's only one thing that it's being affecting. 8x to the 4th y. And the reason why I put the negative up and not down is if I put it down, they wouldn't be like denominators. One would be positive, one would be negative. So I'm going to put it up top. That leaves me with negative x over 8x to the 4th y. We can cancel the x's because it's being multiplied. And when we take 1x from the numerator and 1x from the denominator, that leaves me with negative 1 over 8x to the 3rd y. So we took 1 from 4 of them. Still like denominators. This time we are going to distribute that negative into both of the numerators. X minus 3y minus the quantity x plus 6y. Take the time, write it out. Took me 2 seconds. Now we can show the distribution. Which will give me negative x minus 6y all over 8xy squared. Let's combine like terms. We have x and negative x. We have negative 3y, negative 6y. That makes negative 9y over 8xy squared. Everything is being multiplied in the numerator. Everything is being multiplied in the denominator. So we're going to cancel out one of the y's in the numerator with one of the y's in the denominator. And my final answer would be negative 9 over 8xy. The 9 and 8 don't have a common factor. Still common denominator. Let's put all the numerators together in the numerator. And let's write our common denominator. Like terms, a and a make 2a. We're adding. The only time it makes a squared is when we're multiplying, but we're not multiplying. We're adding a and a, which makes 2a. We have negative 5b and positive 3b, which makes negative 2b over 330a squared. Let's look at that numerator. Is there anything I can factor? Yep. Let's factor out a 2. If we factor out a 2, that leaves us with a minus b. You're factoring from both of the terms, and that is 30a squared. We can cancel the 2 with the 30 now because they're multiplying. And I'm left with a minus b over 15a squared. I cannot cancel the a's anymore because that a is being added and subtracted to b. All right, same thing, common denominators. I'm going to put all of the numerators together. 2x minus 6y plus x minus 2y over 25y. 2x and x makes 3x. Negative 6y, negative 2y makes negative 8y over 25y. Nothing cancels. If I look in the numerator, 3x minus 8y, there's no coefficient or variable that I can factor out. So that would be my answer. We have a negative. Let's be aware of that. We're going to distribute it. 6x minus 6y minus 4x minus 5y all over 25x to the fourth. 6x and 4x makes, 6x and negative 4x makes 2x. Negative 6y and negative 5y makes negative 11y all over 25x to the fourth. Can't factor anything out of the numerator. Nothing cancels. 16u, u minus 3v plus u plus 5v all over 16u. U and u make me, just kidding. U and u makes 2u. Negative 3v, positive 5v is positive 2v over 16u. We're going to factor out a 2. We get u plus v all over 16u. We're going to cancel the 2 and 16. And my final answer is u plus v over 8u. Nothing else cancels. All right, last one. M minus 6n plus m plus n all over 24 mn. M and m. I was thinking of something witty. Negative 6n plus n, negative 5n all over 24 mn. Nothing factors in the numerator, so we can't cancel or simplify that any further. Here's our first unlike denominators. So we need a common denominator. And there's a couple ways to do it. We can find the LCD, aka LCM, and we take our denominators, 6 and 6x, and we're going to find the prime factorization of both. 6 gets broken down to 2 and 3, 6x gets broken down to 2 times 3 times x. So the first thing we're going to do is we're going to circle what they have in common. So what do they have in common? They have a 2 in common, they have a 3 in common, and then the L is the leftovers. What do they have left over? They have an x left over. So my LCM is what they have in common, a 2 and a 3, and then what they have left over, which is x. So my LCM is going to be 6x. 6x, 6x. Now, I know what my common denominator is, so this is step 1. Step 2 now is find equivalencies. Find equivalent fractions. So I need to find 4x over 6 is equivalent to how many 6x's? That's my common denominator. So I asked myself, 6 times what gives me 6x? 6 times x. And if I want them to be equivalent, whatever I multiply my denominator my fraction by my denominator needs to be the same, because this is a value of 1. We don't want to change the value of the fraction. We just want to find an equivalency. So 4x times x is going to give me 4x squared. So 4x over 6 is equivalent to 4x squared over 6x. Now I have 5 over 6x. And I have to find its equivalency to 6x. So what do I multiply 6x to get 6x? Multiply it by 1. If I multiply the denominator by 1, I have to multiply the numerator by 1. And we notice that they're the same fraction. So that makes sense. We have like denominators. Let's combine their numerators. Now, is there a common factor in the numerator? Nope. Can I cancel the x's or the 4 and the 6? Nope, because it's being subtracted from 5, or 5 is being subtracted from it. So that would be my answer. Some people want to, I'm going to do this not in the most efficient way. Remember, I told you in order to find a common multiple, we can just multiply these two denominators. 6 times 2x gives me 12x. That definitely is it's a common denominator. It's just not the least common denominator, but it'll still work. So we can just multiply the two denominators to get a common multiple, aka common denominator. And now we have the equivalencies. 2 over 6 equals what over 12x? So what do I multiply 6 to get 12x? I'm going to multiply it by 2x. Well, of course, because remember, how did we get 12x? We got 12x by multiplying 6 and 2x. So when I ask, what do we multiply 6 to get 12x? Yeah, it's the other side of that fraction. It's the other denominator. And what we do to the denominator, we have to do to the numerator. So we get 4x. My other equivalency, 6x over 2x equals how many 12x's? So what did I multiply 2x to get 12x? I multiplied 6. Well, yeah, hello. Remember, 2x times 6 gave me that 12x, produced that common denominator. So that gives me 36x. We have like denominators. Let's add their numerators. Write it over the denominator. 4x and 36x are like terms. That makes 40x over 12x. Now we can cancel this. We can simplify. We would want to look at the coefficients, 40 and 12. We can do this because it's multiplying to the x. So what goes into 40 and 12? 4 does. 4 goes into 40 10 times. 4 goes into 12 3 times. And now we're going to look at the variables. We have like variables. X over x equals 1. So my answer is going to be 10 over 3. These are going to cancel. My x's are going to cancel because we have x over x, which equals 1. When we cancel, it doesn't equal 0. It equals a value of 1. So that leaves us with 10 over 3. This time, we're going, and here we go. Some of you didn't choose 12x as your denominator, your common denominator, your LCD. Your LCD, let's do this. Least common multiple of 6 and 2x. 6 and 2x. 6 is 2 times 3. 2x is 2 times x. LCM. What do they have in common? A 2. What do they have left over? A 3 and an x. So my LCM is what they have in common, a 2, what they have left over. So 6x would have been my LCD, least common denominator. So some of you chose 6x, and you still would have gotten 10 over 3. So I'm going to work with the lowest common denominator. LCD of these two of these two fractions is 4y, and that's what you're shooting for. You should be able to look at two denominators and tell me what the common denominator, the least common denominator. All right, now let's find equivalencies. Well, it already has 4y as a denominator, so that numerator is going to stay. I don't even have to do any work. Let's think about it logically. If we haven't changed the denominator, we won't change the numerator. Those are going to stay. Don't even, you should be at 30,000 feet in order to see that we're not even changing the fraction. So it's just going to be the same one if it has the same denominator. So what do I multiply 2y to make 4y? I'm going to multiply it by 2, and we get 6x. So I have like denominators. Let's combine their numerators. We have x plus 2y plus 6x all over 4y. X and 6x makes 7x plus 2y over 4y. I can't cancel the y's. I can't cancel the 4 and the 2 because there's nothing I can factor out of the numerator to turn it into addition and subtraction to multiplication. So that's my final answer. Common denominator is 6b, least common denominator. So we have 6 over 2 equals 6b. What are we going to multiply 2 to get 6b? 3b, which gives me 18b. What do we multiply 5 over 3b to make 6b? We're going to multiply 3b by 2. That gives me 10. And something that we didn't discuss back here is order. Right? Make sure your numerator is in standard form. X's come before y's. And we see that here with this one when we have 18b plus 10 over 6b. Now, you always have to check your numerator. Can I factor anything out of those two? Yes, you can. You can factor a 2. So it's 2, 9b plus 5. You're pulling a times 2 from each of those. And now we can cancel the 2 and the 6, which makes 3. So my answer is going to be 9b plus 5 over 3b. Don't forget that b. Just because you've canceled the coefficient doesn't mean that you forget about the variable. These b's cannot cancel. The 9 and the 3 can't cancel because it's not being multiplied. There's a 5 being added to the 9b, and we can't cancel the 9 and the 3 or the b and the b. 3xy is going to be my LCM. Let's do equivalencies. What am I multiplying 3 to get 3xy? I'm multiplying by xy. So we get 5xy. What do we multiply 2, 3xy to get 3xy? We multiply by 1, so we're not going to change that. That's the same denominator. Let's combine their numerators. You have 5xy plus 2 over 3xy. That's our answer. Can't factor anything out of the numerator. 4x and 5x, LCM, 20x. So 2 over 4x equals 20x times by 5, 10. 2 over 5x equals 20x. Let's multiply by 4. 10 plus 8 over 20x. 10 plus 8 is 18. Over 20x. We can cancel the 18 and 20 because it's being multiplied. Dividing it by 2, you get 9 over 10x. How nice and fun was that one? 6x and 3x squared is going to give me 6x squared. Let's do that LCM just so you can check it. 6x is 2 times 3 times x. 3x squared is 3 times x times x. LCM, what do they have in common? They have a 3 in common. They have an x in common. And then what do they have as leftovers? They have a 2 left over and an x left over. So my LCM is going to be 6x squared. 6x squared and 6x squared. Now equivalencies, 6 over 6x equals what over 6x squared? we're going to multiply 6x by x. So I have to multiply my numerator by x, which gives me 6x. And then we have 6 over 3x squared. 6 over 3x squared. That's my denominator, my common denominator. What do I multiply by? 3x squared to get 6x squared times 2 gives me 12. Oh, I like this one. This is a good one. We have like denominators. Let's put our numerator up there over my common denominator. Let's look at that numerator. Can we factor? Is there a common factor amongst 6x and 12? Yep. Let's factor out a 6. We get x plus 2 over 6x squared. We're going to cancel the 6's. That leaves me with x plus 2 over x squared. That's my answer. I can't cancel the x's because 2 is being added to the numerator x. That's a good one. That's one of my faves. 6v and 6u. The least common denominator is not 36uv. It is 6uv. uv, ooh, minus 6uv. So look at this. This is crazy. All right, now we have u minus 6v. That's a good one. All over 6uv. Sorry, 6v. That's my starting fraction, and I have to find a common denominator. So what is the equivalency to that? So what do we multiply 6v to get 6uv? We're going to multiply by u. So when we multiply by u, we have to multiply both items by u. Make sure you do both of the terms here. So u times u is u squared. U times negative 6v is negative 6uv, the alphabetical order. So that's going to be u squared minus 6uv. That one was definitely more complex. I'm going to leave the negative out here, and I'm just going to deal with that fraction because I will distribute it later. So we have 2u over 6u equals, my common denominator is 6uv. So what am I multiplying this to get? I'm multiplying it by v. So 2u times v is 2uv. 2uv. Now I'm going to attach that negative. Now that my denominators are the same, I'm going to rewrite it as u squared minus 6uv minus 2uv all over 6uv. Oh yeah. This will be a good little test. Who's getting this problem right? We have like terms. Negative 6uv and negative 2uv is, oh, that's somebody calling me. Message. Sorry, can't talk right now because I'm making a video. Campbell. U squared minus 8uv all over 6uv. All right. Many of you stop right there. But remember, our goal, when we think we're done, we look at the numerator and denominator. Is there a common factor? Yes, there is. I can factor out a u. If I factor out a u, I get u minus 8v all over 6uv. And because this is multiplying, I can cancel this one with this one. And I get u minus 8v all over 6v. I can't cancel the v's. I can't cancel the 6 because those things aren't multiplying everything. That was a really good one. That was solid. Common denominator, 12y squared. 12y squared. Equivalencies, 2x over 3y. My starting fraction equals how many 12y squares? I'm going to multiply that by 4y. Gives me 8xy. My other fraction, 5y over 4v squared. Y squared, hello. What do I multiply 4y squared to get 12y squared? 3 gives me 15y. 15y. Okay, put them over the same denominator, 12y squared. Let's look at that numerator. Do they have a common factor? No common number. Nothing goes into 8 and 15, but do they have a common variable? Yes, they do. They have a y. Let's pull y from both of those. That gives me 8x, and that gives me 15. All over 12y squared. We're going to cancel the y's now that they're being multiplied. So I'm left with 8x plus 15 in the numerator, and I'm going to cancel one of these y's, so I'm left with 12y. And last but not least, oh, look how easy this one is. This was super easy. Common denominator is 6m. Mr. Mac went super easy on the last one. Well, you made it this far, so why not? 6m, we're going to multiply by 2. We get 6. We have 5, 6 equals 6m. We're going to multiply by m. Oh, all right, I see where the trickiness is. So when we write the numerator, when we combine them, did you write the variable first? We can't factor anything out of the numerator, and there it is. Now, I got to check and make sure I didn't make any mistakes with each of these answers, so we'll do that. Enjoy, good luck. I hope you did well on this homework assignment. I'll talk to you in class.